Lewis structures focus entirely on valence electrons. Now, I've written down the number of valence electrons each group of atoms have on the shortened version of the periodic table here. So hopefully you see a pattern. Let's start off drawing the Lewis structure of water. Water has 8 total valence electrons, 6 from oxygen and 2 from hydrogen. And the first rule you should know is hydrogen can only form one bond. So we draw our Lewis structure like this and connect the covalent bonds like this. Each covalent bond represents a sharing of 2 electrons. So we have included 4 electrons so far and need 4 more electrons. Since oxygen wants an octet, or 8 electrons, we finalize our Lewis structure by throwing the lone pairs onto oxygen, like so. To check our structure, the net formal charge must be correct. Here is the formal charge formula. The net formal charge does indeed equal to the overall charge of water. So this is the Lewis structure of water. N2 has 10 valence electrons. But unlike the last example, we can't throw our lone pairs like so because both nitrogen atoms must satisfy the octet rule or else they won't be stable. So we can compromise by drawing multiple bonds like here. Now both nitrogens are surrounded by 8 electrons, 2 electrons from lone pairs and 6 electrons from the covalent bonds. Remember, each covalent bond represents a sharing of 2 electrons. We check the net formal charge with the overall charge of N2. And we are done. BH3 has 6 valence electrons. Do you still remember that hydrogens can only form one bond? After drawing our Lewis structure, like so, you may be wondering, where is the octet of boron? Unlike carbon, nitrogen, oxygen, and the halogens, we don't have enough valence electrons for boron to achieve the octet, so it is happy. Note that this does not mean boron cannot do octets. We check the formal charge, and this is complete. CO has 10 valence electrons total. Remember that both carbon and oxygen are desperate for an octet. We manipulate the bonds like so and check the net formal charge, which is 0 in this case, with the overall charge of the molecule. And the Lewis structure is complete. CH3OH has 14 valence electrons. A rule you should know is for oxyacids, which are acids that contain oxygen, you must bond oxygen with hydrogen, except for H2O2. By knowing octet rules and checking the formal charge, we are done. An AOH has 8 valence electrons. Now notice that sodium is a metal, not a nonmetal. Generally, metals and nonmetals together form ionic bonds, which rely on electrostatic attraction, not covalent bonds. Remember that sodium is willing to give up this electron, and the oxygen is quite electronegative to retrieve this electron. So, we get this. And the positive charge on sodium and the negative charge on the OH attract each other. So, you should draw them separately. But still, you want to check the net formal charge with the overall charge of the compound. So this is the Lewis structure.